Ja, greetings Pilots. First of all, für meine deutschen Zuschauer bitte nicht wundern. Das Video wird heute mal in Englisch sein, weil es vor allem primär für die einer Fixed-Wing-Gruppe gedacht ist. Und da sind nun mal sehr viele internationale Mitglieder, deswegen heute mal auf Englisch. So yeah, this video will be in English today for the einer Fixed-Wing group, so everybody does understand what I say. Today is the day. The Stealthwings Raphax will be maidened now. My setup is basically finished, at least the first test setup I built up. Today I will do the maiden with the small 2600 milliamp hours GNB 4S LiPo. And my setup is here in the back, my electronics. I use an X8R receiver. That's one of my basically maiden receivers. Later I will replace them with R9 receivers, but for testing purposes I usually use these. An Maytag F411 WSE wing flight controller, an AKK FX3 20x20 stack VTX I use with these standoffs here just to have a good cooling. This is why I have cut out these openings here to have some fresh air directly over the flight controller and through the compartment. This is an old U-Blox M6N GPS module I had laying around and I just installed it for now. Later this plane will get a few more upgrades, but I want to get the maiden done as soon as possible. In the back here we have a temporary DYS area 35 amp ESC that was already in use in the AR wing in the past and still is in one of my in the long range setup. And in the back here I have a Sunny Sky X2212 1400 kV motor with a 7x6 inch GEM fan blade. I've cut out a little opening here, first of all to route the ESC wires and also to have an air outlet for the inlets here so the air can escape back here in front of the propeller. So and yeah, before I forget it, I have put some Emax 12 gram Metal Gear servos in here. The ailerons and the wings are completely laminated. The fuselage is only laminated at the bottom to get some protection on landings and also to get not too much dirt on the fuselage if I land here in the grass fields. Yeah, in the front there's an old Runcam Swift mini camera, old generation. That was, by the way, the first FPV camera I ever had, and that should be that should do the job for now. Yeah, let's screw this down and then we can power the plane up, and after we have some satellites we are ready for the maiden. And by the way, I have added around 50 to 60 grams of additional weight in the nose here right now. This is because the battery is pretty small. Later I will fly that thing with a 5200 4S LiPo, but then also with a bigger motor. First of all, I wanted to try to test this setup with a pretty small motor to see how it behaves with a pretty weak powertrain. And these weights also will simulate the later HD camera that will come in the front here. So let's connect it up, wait for some satellites, and then we are ready for maiden. Unfortunately, at this point my GoPro tried to mess with me, and everything I got from the head cam during the maiden flight was this little useless freeze frame and the audio files. Yeah, so I can only show you the DVR footage laid over with the audio from the head cam. Okay, now shit is getting serious. I have set up auto launch already and I will try my maiden with auto launch. The grass here is pretty short, so yeah, it should have a soft landing if something bad happens, but let's hope everything goes well. Let's check control surfaces, pitch up, pitch down, pitch left, pitch right, that's all fine. If I go into auto launch mode, which will nicely counteract. That's fine. All directions correct. Yeah, then I hope I will give him a good toss and launch it up in the air. Wind is slightly coming from this side. That's good. And he's up in the air. Wow, that's fantastic. Ooh, very smooth, but it tends to climb all the time. So looks good. It's stable in the air. So I think it's time to switch to FPV. It's not as fast as I had expected. Okay, I don't want to go into the loiter mode right now. So I will do a landing. That was a little bit too fast. So let's come in for a nice smooth landing. It's a little bit far, but landed. Great. Successful maiden. Now I will get the plane, will get my goggles, and then I will fly a nice round FPV. Battery should be plenty, 4.13 volts, so not much used. And let's see if the second flight goes as well too. On the second flight I decided to film the launch externally without head cam, so I can show you the launch and do some voiceover now, and then just show you the DVR and what I did. And as you can see, the launch went pretty well, also with auto launch, and no big issues here. Short time into the flight I realized that it was a really good idea not to use the position hold during the maiden to switch to FPV, because as you can see the artificial horizon is very low below the crosshair. That's not a fault of the flight controller or horizon drift in this case, because all data rings need some angle of attack pre-attached, or depending on the actual airspeed, and in this case the Raphax has a parallel fuselage bottom with the bottom of the rings, so there's no angle of attack built into the ring. That means on a later test I found out that it needs about 10-degree up trim to keep level flight at about 50% throttle and 70-75 kilometers per hour. So I have to do that later in software in iNav. So during this second flight in FPV mode I did also the auto trim. As you can see, some of the items in the OSD are a bit messed up. That's because I forgot to reload the OSD font after updating the flight controller from the default 2.3 to 2.5. This is iNav 2.5.1 I've installed here, and I forgot to re-upload the font, so some of the icons are missing. And as you can see, even with that pretty underpowered setup, the X2212 motor is a very great motor and a very efficient motor. But for a plane weighing 1.2 kilograms, it's pretty weak. It's not made for acrobatics, but as you can see, it still performs really well. So it feels very nice at at a 50% cruise throttle with 60, 70, 80 kilometers per hour. And here I did an stall test, and I was really impressed. The first part was just keeping level without throttle, and here I really ran full pitch up, and as you can see, I still had roll control. It was pitching up and down a little bit on the pitch axis, but I never had the feeling that I lose control in any way. So even during a full stall, it's really, really stable and controllable, and that's really impressive. Then after the auto trim was completed and also the stall test was done, I went into a landing to save the trim, and even there I really landed with a full stall, so I didn't apply any throttle. I just pulled up until it just gently touched down, and that was really fantastic. So, well, Maiden and auto trim flight went fantastic. I was really surprised how well it actually went. What I realized at the beginning was that it was a little bit hard to pitch up, but if I go full throttle, it also tends to pull in the nose up. So I think it just had too little speed at the beginning, so I had to pull pretty hard to climb actually. The stall behavior is really fantastic. I was completely blown away. I cut the throttle and I thought, okay, when will it start to stall? But it just didn't. I had full control all the time. I just realized that my nose was pitched down a little bit, so yeah, it was losing altitude, of course. And then after the turn, I just pulled the trigger fully back. I've given full pitch up, and it still didn't stall. It was completely controllable, completely stable. It was a really great feeling. So now I have done the auto trim. I will check the values in iNav, and then I can continue with the complete tuning. And by the way, I'm still at 4.0 volt resting voltage on the LiPo. So yeah, basically this video is about the Maiden flight. I think that's done now. Yeah, I hope you liked it. I really already like that plane, and I will continue flying it for a while, and also replace the powertrain to get a little bit beefier motor in there. Maybe I will go for an 2814 motor, and then I can also power it with the big 5200 milliamp hour LiPo. Right now it needs to have a really stable flight where I can also do slight climbs. It needs about 50% throttle with that setup and pulls about 4 to 5 amps roundabout. Yeah, but I really hesitate now to put the big battery in here, because that will add another 200-250 grams to the overall weight. By the way, the weight right now is 1190 grams. I weighed that just before I started at home. And with the bigger battery, I could really get issues with that motor setup. If I have to climb rapidly, it really likely would stall. So yeah, I hope you liked it like I did. I will continue a few flights until the battery is completely done, and yeah, thanks for watching and have a nice day. So yeah, a few additions to the final statement after the second flight. I of course did a third flight still on the same battery here, where I tried out a few more things, especially the agility of the plane. And what I realized too was that the artificial horizon is always very low below the actual horizon. That has two reasons. First of all, the camera has a slight down angle, so if I fly level, then the camera will actually watch a little bit to the ground to have a better overview there. And the second thing is that a data ring always needs some angle of attack to fly level, depending on the airspeed. And this angle of attack is not mechanically applied in the build itself. So the flight controller is actually parallel to the bottom side of the wings. And that means that you have to trim the flight controller with a pretty steep up trim to have the correct angle in angle flight modes. And later in this flight, in this third flight, I tried that out, and I found that a 10-degree up tilt is a pretty good value to start with before you tune any autonomous modes. So in this case, that was a good idea to not engage position hold on the maiden flight to set up my goggles, because then bad things could have happened. And also this park was very small. I didn't want to risk any crash in the surrounding area. That's why I decided to stay in that mode. I also tried some auto tune, and what I realized there was that my pitch rate was a little bit too high. I think I have it on 140 degrees per second, and as you can see at the stabilization values, the feed forward value climbs extremely high, because the servo throw is just not enough to actually get that high pitch angle speed. But as you can see, after some movements, the plane went even more stable, although it was really stable from out of the box. And what I used was the mini drag preset in the INAV configurator, and that were very nice starting values. And yeah, by the way, this missing 10 degrees angle of the flight controller was also the reason that the auto launch was so flat. Actually, I set a climb angle of 25 degrees, but as these 10 degrees are missing, it was actually just climbing at a 15-degree angle. Yeah, the weather tomorrow will be nice too, I think, as long as the weather prognosis says. So pretty sure I will charge some more lipos and go out fly again tomorrow, then do some tuning. But I really like how this plane behaves, and I'm really impressed. I have not much experience of building complete DIY planes with laminating and doing all the hinges, the aileron hinges and all that stuff by myself. And I'm really happy how that went and how it actually flies. Arthur has done a very, very nice job here. So as mentioned in the group post before, every group member of the INAV Fixed-Wing group will get a high discount on this plane. So the retail price in the shop will be 149 euros for the full kit and all the mechanical parts included, including also a motor mount that you can select during the shopping. And for INAV Fixed-Wing group members, the price will drop to 124 euro, and this discount will be permanently for all members of the group. I hope you liked it, and if you liked, then please don't forget to subscribe and share the video, and see you in the next time.